Students, welcome back. So today we will start with chapter 9 CBSE NCERT chapter 9 number systems, chapter 1 class 9 chapter 1. I found many students do a search on this, and that made me decide that this is something which people are struggling with, students are struggling with. So let's understand this chapter. First of all, what is a whole number? I'll start with a whole number. No, first you will start with natural numbers. That is the natural numbers denoted by n, capital N. First of all, number line. This is the number line. You know that, right? We have 0 in between. 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4. So this goes infinitely. Now point is, natural numbers are all numbers on the number line starting with 1 and positive numbers 1, 2, 3, and they should be whole numbers, they should not be fraction. 1, 2, 3, 4, 5, 6, all these are natural numbers. 1, 2, 3, dot 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 dot, these are natural numbers. Then we have whole numbers. Natural numbers is easy, whole numbers is also easy, denoted by capital W. There is one 0 added to natural numbers. 1, 2, 3, dot 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 dot. So 0 plus natural numbers, that is whole numbers. So if you include 0, these points, see, each number is a point on the number line, and you know that there can be infinite number of points. So in between 0 and 1 there are many numbers. We will go to that later on. First of all, 0, this is 0, this is 0, right one, this is not O, 0. 0 plus natural numbers gives you whole numbers. Next is your integers. What are integers? So these points are not whole numbers or natural numbers. Minus 1, minus 2, minus 3, they are not natural numbers. Integers is denoted by Z, and it means minus infinity dot 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 to minus 3, minus 2, minus 1, all negative numbers, 0, 1, 2, 3, 4, dot 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 dot, infinity. So all numbers including negative numbers, and all whole negative numbers, I would say, to understand, for the purpose of understanding, whole natural numbers and negative numbers, 0, positive whole numbers, all these are natural integers, they are all integers. So if I ask you minus 81, is it a integer? Yes, it is an integer. Is it a whole number? No. Is it a natural number? No. So understood so far? Now all natural numbers are whole numbers? Yes. Are all whole numbers natural numbers? No, because 0 is not a natural number. So all whole numbers are natural numbers. All natural numbers are whole numbers, but all whole numbers are not natural numbers. Integers. Are all integers whole numbers? No. Are all whole numbers integers? Yes. Are all natural numbers integers? Yes, because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 all are integers. Now next is your rational numbers. This is where things become a little difficult. Rational numbers definition is, you can put it in the form p by q, where q not equal to 0. It can be represented as p by q, in the form p by q, where q not equal to 0, and p and q are integers. So the point is that P and Q are integers. Now let's understand what do you mean by this. If I ask you rational numbers, remember this thing, any number you change it into decimal, how will you decide? Change into decimal. If it is a terminating, good, non-terminating, good. What do you, I'll explain. Terminating, non-terminating and repeating, they are rational numbers. What do you mean by this? I'll explain. So point is, any number, if I ask you 0.312221 give me a second. So change into decimal, terminating, suppose I ask you 1/3. So this you can very well, by looking at the number itself, you can understand that this is a rational number, because it is in the form of P by Q. Q is not 0, 3 is not 0, and P and Q are integers. 1 is integer, 3 is also integer. So, but in fraction, if you divide 3 by 1, you will get 0.33333333, never ending 3. So this is a non-terminating repeating number. So you can write it as 0.3 repeat bar, which means this is, if I ask you, is 2.45454545 ... is it a rational number? You will say yes, because I can simply write it as 2.45 repeating. So they are rational numbers. Any number which is terminating is very good. 0.3. You very well convert that as 2 into 3 by 10. That is a rational number. So these numbers which are terminating, they are always rational numbers. If they are non-terminating like this, but they are repeating at any point of time, it can be something like this: 1 2 into 2 5 7 2 7 2 7 2 7 2 7 2 ... So you see the repetition is here. You see, right? 7 2 7 2 7 2 7 2. This is a rational number, and it can be represented into a P by Q form. So let me rub all this. Now the question is, if somebody gives me 2.575775, change this into P by Q form. How will you do that? So first of all, see, let this be x. So this is ultimately x is equal to 2.575 bar, right? Let x equal to, how do we see that 2.575? We can convert it into P by Q form. Then only we can prove that this is a, see, it is, by definition it is a rational number, because it is a non-terminating thing and a repeating. It repeats here. So it is a rational number. So what will you do? Try to bring till the bar, bring on this side. So you have to multiply by 10. 10x is equal to 25.75 bar. Either this way, or you bring another, another pair, say 75. So that means 1000x. 1000x is 2575.75 bar. You understand, right? You can write 7575. So you multiply it by this, by 2575. Now subtract both. 1000x minus 10x is 2575.757575 minus 25.757575. So what do you get? 990x is equal to, when you subtract 2575.757575 and 25.757575 dot, all this will become 0 and you will be left with 2550. So this is 2550. So x is how much? 2550 by 990. Try to cancel. See, I have this is zeros, right? This is all zeros, so you can remove this. 2550, you cancel 0, you cancel by 9, 11, 9 2s are 18, no, not 9, 3, 33, 3 8s are 24, 3 5s are 15, 85 by 33. Now let's see, 85 by 33, is it really giving me that result? If you divide, you will find 33 2s are 66, 9 1 point 0, 5s are 165, 25 0, 33 7s are how much? 33 into 5, 165 and 66, 165 66, 231, 231. So that gives me 190. Again 5. See, this thing is getting repeated, this whole chunk is getting repeated. You'll get 165, you subtract, you get 25, and it keeps on going as 57 57 57. So point is, this is the way you convert any bar number or non-terminating repeating into P by Q form and show that it is a rational number. Okay. Now let's move on to the next topic, which is irrational numbers. What are irrational numbers? And another thing, where does it stand? Where does it stand on the number line? Very easy. 2.5, you have, it is this one and a little greater than this. So this is the point. Around this point, this is 2.5757. So what are irrational numbers? That is a little difficult. That is something which makes you understand, makes you feel like I am dropping all this. What are irrational numbers? So irrational numbers are a little tricky numbers. By definition, they are non-repeating, non-terminating and non-repeating. They don't even repeat. Like I have the value of root 2 as 1.414562 48801 dot. I mean, you go on till infinity, but you will never find a sequence, repeating sequence. Never. Those numbers are known as irrational numbers. But numbers which are, when you find square root by the method you have been taught, right? So I am not going into the finding out of square root. Even if you go give it in calculator, it will give you, I mean, you can do thousands, you can go on dividing like this. You will never get a sequence where you can say, oh, this, say there was a number like this, 2.1 point something like 1.414236412336. I get a repetition here. So this is a rational number, but this one is not. You never find out a sequence, repetition, non-repeating, and terminate. It's not even terminating. Terminating means 1 by 2 if you do. It's a very simple thing. 2.0, 2 5s are 10. Your remainder comes out as 0. This is not terminating. It terminated. You don't find any. You will get the remainder 0. Stops the division part. So this is where irrational numbers come into picture. Irrational numbers are non-terminating. They keep on. They never end. Then the decimal, it never ends means the remainder never comes out to be 0, and you keep on doing and you never get a sequence, non-repeating. It's not repeating at any point of time. Those numbers are called irrational numbers. Are they present on the number line? Yes, they are present on the number line. How do you find? If you are said find out rational number on the number line, if I say to root 2, you know Pythagoras theorem, base square plus perpendicular square is hypotenuse square. So root 2 is square root of 1 square plus 1 square, right? So say this is, you draw this much length, you take this much length, okay, you draw another this much length. So this is 1, this is 1, and you join this. You take a compass, measure this and rotate like this. This is your 1 point, this is root 2. If you are asked 0, 3, break it into 2 sums. This is root 2 square, 2 plus 1, 3, root 2 square plus 1 square. So this hypotenuse, you know root 2. Take this length, draw that length, join this. It should come within, it should come like this. So any number, if it is 5, represent on the number line. This is 4 plus 1. So this is 2 square plus this is 1 square. So this is very easy. On the number line 0, 1, 2, you take this 2, you go above 1, measure the hypotenuse, and this is root 5. So this is how you represent on number line. Now let me see if I can cover anything. How many rational numbers? So this is all about irrational numbers. Now in class 10 you will find that there are some numbers which we take use of, which do not even exist on the number line. They are illogical numbers, imaginary numbers, they don't exist. But numbers which exist on the number line, they are called rational numbers, real numbers. So what are the numbers which cannot be, which are outside the number line? Those are unreal numbers or imaginary numbers, which you will not study at this point of time. We'll come to that in a separate session. We'll cover that, but that is class 10 topic, and we'll do those. but I hope this was clear. If there are any questions, you can definitely see. I can solve many problems. Maybe the problem solving session we can do, we can cover in another session on real numbers. This is number systems we can cover on in a separate class. But today we'll close here. So I hope you are clear with natural numbers, whole numbers, rational numbers, integers, how to represent on the number line. If there are any questions, put it on the comments box and let me know. I'll definitely explain that to you. Try to solve some problems. So I'll close here. Hope the session was useful. Thank you so much for watching. Please do subscribe my channel to see more videos coming up. They are on the way as time progresses. Thank you so much. Have a nice day.